Hello, welcome to this video on magnets. Here are the objectives for this video. So, a magnetic material or magnet and an electromagnet and the Earth all have magnetic fields around them, and we can describe them by drawing field lines around them which show the strength and direction of the field. Now, there are 4 different magnetic materials, which are iron, steel, cobalt and nickel, and they can all be attracted by a magnet. Now, when we have a magnet, if we have 2 opposite poles, a north and a south, those poles are going to attract each other. So you can see here, those get pulled together. Whereas if you have 2 similar poles, like a north and a north or a south and a south, those are going to repel from each other and push the 2 magnets apart. Now, this is an important property of magnets. If you just have a magnetic material, it can't be repelled by a magnet. A magnetic material that isn't a magnet itself can only attract to a magnet. Only another magnet can be repelled by a magnet. Okay, so just the last diagram here showing that repulsion between 2 south poles. Now, how can we draw this thing called the magnetic field? Well, we draw it using field lines, and they flow from what we call the north pole or the north-seeking pole to the south pole or south-seeking pole. Okay, so if we start with our bar magnet here, add in a north and a south pole. So our field lines go from the north end of the magnet to the south end, and they go along the sides as well. One common mistake is that people make is that they put just out of the ends of the magnet when they're drawing the field lines, rather than along the sides as well. Now, important properties of the field lines is that you can use them to see how strong the magnet is by how close the field lines are together. So in the places where the field lines are closest together, that's where the magnet is going to be strongest. The magnetic field is going to be strongest. So at the ends of the magnet, you've got those closer together field lines, which is why it feels a stronger force there than at the sides of the magnet. We draw arrows on to show the direction of the magnetic field, and we always draw that going from north to south. Okay, so you also need to be able to draw multiple magnets and how they interact with each other. So you can see there 2 unlike poles attracting. The north pole sends its magnetic field across to the south pole, and you see the field lines there. Whereas if you have like poles repelling, you can see the field lines are pushing against each other, and that's what creates that force of repulsion. So the Earth. The Earth has its own magnetic field because it's got an iron core, and that's magnetized. It's like having a giant bar magnet inside the Earth. Now, the slightly confusing thing is, in our north pole, there is a south-seeking magnet, and in our south pole, there is a north-seeking magnet. So our field lines actually go from the south pole round to the north pole, which is why when we're using a compass, its north pole points towards the north. Okay, so a compass is just a very small magnet that's able to change direction easily, and that's how we can use it to point to the north. Okay, thank you very much for watching.